Hi everyone, today's lesson is a review of ellipses and hyperbolas. So let's get started. So the first question is, find the equation for an ellipse with a major axis of 12 and a foci points at 1, 3, and 1, 9, and also graph. So for this problem, let's start off with graphing the focal points, and that's going to be at 1, 2, 3. There's 1 focal point, and then the other one's going to be at 1, 9, which is all the way up here, and that's another focal point, and that's at 1, 9. What I see is the distance between the focal points is 1, 2, 3, 4, 5, 6, 9 minus 3. And so that means that if I were to cut that in half, then I would have a center point right here, and that center point would be 1, and this is 3, 4, 5, 6. So 1, 6. And this point here is 1, 3. So what that means is, if this is an ellipse, that I know a couple of things. That I know my center is at 1, 6. So we would start off by going x minus 1 quantity squared plus y minus 6 quantity squared, and this is equal to 1. And don't forget, you've got these values. To put it in standard form, you have values underneath both x and y. So that means that what I do know is that my c value is 3. All right, this value right here is my c value, and that makes 3. In addition to that, I know that the major axis length is 12. Now remember, the focal points are always on the same axis as the major axis. So from the center here, I know that I would go up 6 and down 6. So I've already gone up 1, 2, 3. So 4, 5, 6. So this point right here is an additional 3 above that. So that's going to be 1, 12 is one of my vertices. And then again, I would go down 1, 2, 3, 4, 5, 6. And this point here, 1, 0 is another vertex. So that means that I know this value here is my A value, and my A value is going to equal 6. So from my focal point formula, I know that I know that c squared is equal to, so c squared is equal to a squared minus b squared. And so we know that c is 3, so that's going to be 9, is equal to a squared, which is 6 squared, which is 36, and then minus b squared. So that I know that when I subtract 36 from 9 minus 36, I'm going to get negative 27, divide by negative 1. I'm going to get b is equal to the square root of 27. So, but b squared is equal to 27. So remember that if I went up 6 units on the y-axis, this value right here is 36, and that's my major axis. My b value is going to be 27, and that's going to be right here. Because remember, a is greater than b for an ellipse. Okay, so my standard form for my equation is this right here. For number 2, it says find the standard form of the equation for ellipse. So this is the second problem for ellipses. State the center, the vertices, and the focal points. Graph the ellipse. So for this problem, we are going to complete this square. And because I have an x squared term and an x, and a y squared term and a y, oops, this should equal 0. That means that I am going to complete the square 2 different times. So let's group our x's. So we're going to have 4x squared minus 32x. I'm not leaving any space because I am going to rewrite this again. Plus y squared plus 16y, and I'm going to move that 124 over to the other side. So equals negative 124. So in completing the square, I know that my y squared coefficient, which is the value right here, and my x squared coefficients have to be 1. So that means that I do need to factor out anything that's in front of my x squared or my y squared terms, including a negative sign if I had that. So we're going to take out a 4 from this, and we get x squared minus 8x. Now, half of 8 is 4. 4 squared is 16. Plus, now we're going to complete the square again. Y squared plus 16y, half of 16 is 8. 8 squared is 64, is equal to negative 124 plus, now remember, temporarily we factored out the 4. You have to put that back in. So 4 times 16, which is 64. And then you've got, I added 64 again, so plus 64. So in this problem right here, I've got negative 124 plus 64, which comes out to be 4. So let's see, we have 4 times the quantity, let's factor. X minus 4 times x minus 4, quantity squared, plus y plus 8, quantity squared, is equal to 4. Okay, so if this 4 wasn't here in the front, that would actually be a circle, right? But because the 4 is there, I do need to put this in standard form. So I'm going to divide everything by 4. Everything gets divided by 4, and I'm going to get the quantity x minus 4, quantity squared, over 1, plus y plus 8, quantity squared, over 4, is equal to 1. And so this is my equation of my ellipse in standard form. My center, so you're going to have to list all these attributes to the ellipse. So my center is at 4, negative 8. So I'm going to actually start graphing this, okay? So in graphing this, I'm going to type it, I'm going to put in 4 and then negative 8, so that's right around here. So that's my center, 4, negative 8. In the x direction, I'm going to take the square root of whatever's underneath the x. So the square root of that is 1. Square root of 1 is 1. So that means in the x direction to the left, I'm going to go 1, and to the right, I'm going to go 1. And additionally, underneath the y-axis, I'm going to go the square root of 4, which is 2. So I'm going to go up 2 and down 2. And then I'm going to connect my dots, or my vertices. This value, which is my major axis because it's larger, this is equal to a squared. So that means a is equal to 2. This value is equal to b squared. So that means b is equal to 1. But to find my major axis is equal to 2a. So that's 2 times 2, which is 4. So if I just counted, that would be okay also. My minor axis is going to equal to 2b, which is going to be 2 times 1, which is 2. So what I have now is I've got this shape, and the last thing I need to resolve is what my focal points are. So c squared is equal to a squared minus b squared. So I do need to find my focal points. So c squared equals 4 minus 1. So 4 minus 1 is 3. C is equal to the square root of 3. Because my focal points are always on the major axis, right? I'm going to add my focal points to my y coordinates. So you're going to have to label this point and this point. These are my focal points. You're going to have to label those. So in order to label those, you're going to say parenthesis 4, negative 8 plus the square root of 3. And this point right here is going to be 4, negative 8 minus the square root of 3. So now we have all the values for that. And one last thing, when they ask you for the vertices are the endpoints right here, which are on the major axis. So make sure that when you're on the major axis, the vertices are on that major axis. So like this point and this point, you would need to label. Okay, so number 3 says find the standard equation for the ellipse. State the vertices, the focal points, graph the ellipse. So for this problem, again, I see an x squared term and an x. I have a y squared term and a y. So I am going to complete the squared twice. So let me separate my x's and y's. So we have 4x squared minus 24x plus 25y squared plus 250y is equal to negative 561. I need to complete the square. In completing the square, I do need to factor out anything that's in front of my squared terms. So we're going to factor out a 4. So I get x squared minus 6x. Now half of 6 is 3. 3 squared is 9. I'm adding 9 to the left. I'm going to factor out a 25 at the same time. I get y squared plus 250. Take out 25, so that's what, 4 per 100. So that's 4, 8, 9, 10. So we have 10y. Now half of 10 is 5. 5 squared is 25. And what I have on the right is negative 561. And remember, you've got to put those values back in. So if I temporarily factored out that 4, I do need to add it back in. So it's 4 times 9. So that's going to be plus 36. And I have 25 times 25, which is going to be 625. So factoring, I get 4 times the quantity. So that's a 4. 4 times the quantity x minus 3. Let me write that. 4 times the quantity x minus 3 times x minus 3. So that's quantity squared. Plus 25 times the quantity. Y plus 5 times y plus 5, that's quantity squared, is equal to, this is going to add up to be 100. I'm going to divide throughout. To put this in standard form for an ellipse, I do need to have this value right here be 1. So I am going to divide out 100. And so this is going to equal 1 on the right. This is 100 divided by 4, which is 25. So I have x minus 3 quantity squared over 25. Plus, and this is going to be 100 divided by 25, which is 4. So we're going to have y plus 5 quantity squared divided by 4. And this is my equation of my ellipse in standard form. So now what we need to do is we're going to need to graph that. So in graphing that, we're going to start off with our center. So our center is at 3, negative 5. So I'm going to put that at 3, negative 5. I'm going to make this just a hair bigger. Okay, let's see. So 3, negative 5. So 1, 2, 3. And then 1, 2, 3, 4, 5. So that's about right here. So 3, negative 5 is my center. So basically it's going to look something like that. I know that if you look under the x value, you're going to see it's square root of 25. Now, in this case, because it is an ellipse, this is equal to a squared, okay? And so to the right and to the left, I'm going to go 5. So from my center, I'm going to go 1, 2, 3, 4, 5 to the left, and I'm going to go 1, 2, 3, 4, 5 to the right. In the y direction, I'm going to go the square root of 4, okay? And that's going to be 2. So I'm going to go up 2, down 2. I'm going to connect my points. And so where my vertices are these points here, because that's my major axis right there. So when they ask you what your vertices are, you're going to say those values. Those are my vertices, okay? So that's what you have to say. So that point right there for that vertice is, I think it's negative 2, negative 5. And this point right here, 5 and 3 is going to be 8, negative 5. Additionally, you're going to need to know what so these are my vertices. Additionally, you're going to need to know what your focal points are. So where are your foci? So what you're going to do is you're going to use your formula, which is c squared is equal to a squared minus b squared. We have a and b, so we're going to go c squared equals 25 minus 4. So c is equal to the square root of 21. Because my focal points are on the major axis, and my major axis is x, it goes horizontal, that means that I'm going to add my focal points to the x coordinate of my center. So meaning my focal points are going to be at 3 plus the square root of 21, negative 5, and 3 minus the square root of 21, negative 5. And so those values, those focal points are going to be on here and here, but the points of those, you've got to, oops, that's the minus 1. So that's the minus 1, and this is the plus 1. Okay. Number 4 says, find the equation for the ellipse that has a center of negative 2, 3. So this one didn't give us any information other than that we're trying to find the equation. Now remember, we have our standard form is x minus h quantity squared over either a squared or b squared plus y minus k quantity squared over a squared or b squared is equal to 1. And remember, if the major axis is on the x-axis, then x is going to, underneath here, it'll be a. It says the length of the major axis is a, that didn't tell us it yet, but it did say the major axis is vertical, which means that this is going to be my a squared and this will be my b squared. It says that the center is at -2, +3. 1, 2, 3. So there's my center. Okay, so that means it's going to go like that. So far, I actually know that I have x plus 2 quantity squared plus y minus 3 quantity squared is equal to 1. And so these are going to have values underneath. It says that the length of my major axis is 8. Now, they also said that it was vertical. So if it's 8, the length is 8, it's going to go up 4, and it's going to go down 4. Okay, which means that at -2, -1 is one of my vertices. Okay, and at -2, what is this? It's going to be 3 and 4 is 7. So at -2, 7 is my other vertice. It also, so basically up, I went up 1, 2, 3, 4. So on the y direction, I went up 4. So that means this value right here is 4 squared, which is 16. It says that the length of my minor axis is 2. Well, that's just 1 to the right and 1 to the left. So that means 1 squared. So that's just 1. Also, graph the ellipse, check, we did that. And so we have the standard form of the equation. And the last thing we need to do is to write the points of the coordinates of the focus points. So we're going to go c squared is equal to a squared minus b squared. C squared is equal to a being bigger, 16 minus 1. So c is equal to the square root of 15. Let's see, 16 minus 1. Yeah. And so therefore, this point right here, which is my center, I always say to write the center down, which is -2, +3. So my focal points are going to be parentheses. They're going to be, because they're on the y-axis, they have to be around here and here. Being on the y-axis, I'm going to add my foci to my y-coordinate. So it's going to be -2, 3 plus or minus the square root of 15. And so those are my focal points. All right. Next question is, now we're switching to hyperbolas. And it says, given the equation of a hyperbola, find the center, the vertices, the foci, and the equation of the asymptotes, and then graph. Now, for this problem right here, I noticed that I have an x squared but not an x. And I notice I have a y squared, but not a y. So what that's telling me is I do not have to complete the square. So all I have to do basically now is divide this by 400. And I know that this is a hyperbola, by the way, because of this minus sign right here. That differentiates the ellipses from the hyperbola. So what we have is x squared over 400 divided by 25, that's 16, minus y squared over 400 divided by 16, which is 25, is equal to 400 divided by 400, which is 1. So here's the standard form for my hyperbola. If I don't complete the square, what that does is it tells me that my center is at 0, 0. Now, in the x direction, I'm going to make this a little bit bigger. In the x direction, I'm going to look underneath what's under my x, and I'm going to go the square root of that distance. Okay, so you're going to take the square root of 16. The square root of 16, which is 4. So that means I'm going to go 4 to the right, 2, 3, 4. Put a point, 1, 2, 3, 4. Okay, in the y direction, I'm going to go the square root of 25, which is 5. So I'm going to go up 5. 1, 2, 3, 4, 5 up, and 1, 2, 3, 4, 5 down. Do not connect these points, because if you connect these points, what that's doing is, if you connect these points, you just made this an ellipse. But what you are going to do is you are going to actually create a box that is going to go around this, because you have to distinguish that this is a hyperbola. So we know we have a box like this, okay? We have our box. And what you're going to do is you're going to put in your asymptotes. And your asymptotes basically goes from one corner to the other corner, right? And so by graphing this way, this is one way to graph. Some people will always graph by their asymptotes, but I'm just graphing with the box. So now what I'm going to do, okay, is I'm going to go, okay, which one is positive? Is my x positive or is my y positive? If my x is positive, okay, then that means that my graph is going to be on the x-axis. If x is positive, x squared is positive, okay, that's our positive coordinate. That means the graph is going to go to the left and to the right. If y was positive, meaning if it was a negative x squared plus y squared, the graph would be going up and down. So because x is positive, you're going to put your vertex, that's your vertex here, not that. There's your vertex, and your graph is going to follow your asymptotes. Okay, and then here's another vertex here. Your graph is going to follow your asymptotes. And that's it. So a couple of other things. We still need to find our focal points. Okay, so we are going to find the foci. And so let's do that first. So foci are going to be at c squared equals a squared plus b squared. Now this is different than an ellipse, because in an ellipse you're subtracting. So to find my foci, I'm going to go c squared is equal to 25 plus 16, and 25 plus 16 is 41. So we have c equals the square root of 41. Okay, which means that because my center is at 0, 0, I actually just have to go to the right. The square root of 41. So that's going to be the square root of 41, comma 0. And this foci over here will be the square root of negative square root of 41, comma 0. All right. Additionally, there's a couple of terms that you should know. This term that connects my vertices from here to here, that's what we call the transverse axis. So that's the transverse axis, and that actually connects the vertices. Remember, the focal points always have to be in the arc. Whether you have an ellipse like this, right? Here's my arc. Your focal points are inside, right? Or if I have a hyperbola like this, your focal points are going to be inside. So that's really important that you always remember that, all right? I think I just erased this, which was, what was this, 16? Yeah. Okay. So that's the transverse axis that connects my two vertices, vertice. The other axis actually has a name as well. This is this length here. That's called, that right there is called the conjugate axis. We don't really do anything with that other than they may give you a conjugate axis and say, okay, come up with the equation. But so sometimes you're going to be asked what the conjugate length is, and that would be just this length here times 2, which in this case would be 5 times 2, which is 10. So my conjugate axis is length 10, and my transverse axis has a length of 4 and 4, which is 8. Lastly, the last thing you needed to do for this problem was to find the asymptote equation. For me, when I'm doing these, I always use this formula, and it looks like this. It goes y is equal to plus or minus the square root of whatever the rise over the run is, which it means my y coordinate over my x coordinate, rise over run. And don't forget the x, because these are actually lines, so you do need an x there. So we're going to go y is equal to plus or minus. Now, what's the square root of my rise over my run? 25 over, what's the square root of 25 over 16? X. So this, my asymptotes equation is going to be y equals plus or minus 5 over 4x. Now, that's to use like a formula kind of thing. That's my formula right here to find the asymptotes, all right? However, remember, you can always just count, right? To find the asymptote, you go rise over run. So that's just going to be up 5 over 4, right? Down 5, left 4, up 5, left 4. So you can use, you can just count as well. For number 2, it says same kind of problem, but in this case, we are going to complete the square. So I'm going to group my x's. So I've got 4x squared plus 8x minus y squared minus 4y is equal to 4. So what we have so far is I've got x's and y's, and so in doing that, I notice that I have a value in front of my x squared term, so I'm going to need to temporarily factor that out. So we have x squared plus 2x, half of 2 is 1, 1 squared is 1. Now, this is the part that a lot of people will mess up on just because they forget that you have to factor out this negative sign right here because the y squared term and the x squared term have to have a value of 1. So I'm going to factor out that positive one. So I'm going to factor out that negative sign, and I'm going to get y squared plus 4y, right? Because when you factor, you're dividing, and you're dividing by negative 1, it makes it positive. Half of 4 is 2. 2 squared is 4. And this is equal to 4. And now remember, you've got to put back the factors that you temporarily took out. So we temporarily took out 4 times 1, which is 4. And we temporarily took out negative 4 times 4. So that's negative 4. So factoring, we get 4 times the quantity x plus 1 times x plus 1, which is x plus 1 quantity squared, minus y plus 2 times y plus 2, which is y plus 2 quantity squared. And this is going to equal, these cancel, just 4. Remember, for standard form, you do need there to be a 1 here, but also no values in front other than the negative sign. No values in front. So we're going to divide everything by 4. So divide by 4, divide by 4. And so we're going to get 4 divided by 4 is 1. So we're going to get x plus 1 quantity squared over 1 minus y plus 2 quantity squared over 4 is equal to 1. So this is the standard form for my equation of my hyperbola. And I know it's a hyperbola because of this minus sign. Ellipses would just have 2 positive values there. Okay, but this being a hyperbola, it's a negative. So my center of my hyperbola is at negative 1, comma, negative 2. So negative 1, negative 2, so it's around here. And I like to write it there, but I'm going to wait for just a minute. In the x direction, I'm going to take this value and go the square root of that in the x direction, which means I'm going to go 1 to the left and 1 to the right. In the y direction, I'm going to take the square root of that, which is up 2 and down 2. So up 2 and down 2. And do not connect the points because this is a hyperbola. You cannot connect this. What you need to do is make a box. So we're going to box this up. And so it's just a very small difference between an ellipse and a hyperbola. Remember, if it's a hyperbola, there's 1 negative sign. And so we're going to put in our asymptotes, and our asymptotes are going to come down like that and like that, okay? And because my x term is positive, my graph is going to be on the x-axis. So therefore, there's my vertice, and my graph is going to follow my asymptotes, follow the asymptotes, and it's going to look like that, okay? Remember that if the x-coordinate had been negative, my graphs would have gone up and it would have gone down as well. We need to find out where our focal points are, and so we're going to go use the formula c squared. Let me make this go up. C squared is equal to a squared plus b squared. Remember, for an ellipse, it's a squared minus b squared. So you've got c squared is equal to, the difference between a and b in a hyperbola is that a is just the positive value. So it doesn't have to be greater than, whereas in an ellipse, your a value is always greater than b. But in a hyperbola, it does not have to be, as you saw in the last example too. So for this one, a is 1 because it's the positive 1 coordinate. And then so we have plus 4. So c is equal to the square root of 5, which means that this being my transverse axis, right, that connects the two arcs, the two hyperbolas, from the center is at negative 1, comma, negative 2. From the center, because it's on the x-axis, I know my focal points are going to be in here. Remember, they always have to be cupped. They have to be cupped by the arcs or your hyperbolas. So this point here is going to be negative 1 plus the square root of 5, comma, negative 2. And this point right here will be negative 1 minus the square root of 5, comma, negative 2. So if I wanted to write those out, my focus points would be negative 1 plus or minus the square root of 5, comma, negative 2. The last thing I need is to write down what my asymptote values are, or my equation for my asymptotes. So my asymptotes are going to be y is equal to plus or minus. And again, it's the square root of the rise over the run. So it's going to be 2 over 1. So plus or minus 2x. And so those are my equation and my asymptotes. And again, you're absolutely welcome to just count up to over 1, and that's fine. Problem number 3 is a hyperbola. Find the equation of a hyperbola with the following. We have asymptotes as the rise over run. So I already know that this value right here, this is my rise. So that would have to be 9, and this would have to be 4. It also tells me that I have a vertex at 0, 1, 2, 3. So I have a vertex like this. If it's a find the equation of the asymptote. So this is telling me that this is up 3. See this right here, up 3, which means I got to go down 3 also. Additionally, in between that value means that that's where my center is. So that means that this is just an x squared. This is a y squared. This is going to equal 1. Now, because my vertex is on the y-axis, this is what it's telling me, that this is going like this. Vertex, that's a vertex. So it's going like this. It also tells me that because my hyperbolas are on my y-axis, that my y coordinate is positive, which means that my x coordinate must be negative. And we've graphed that. The only thing that, and this is my standard form for my equation, the only other thing that I would say is some people will write this the other way. So they'll go y squared over 9 minus x squared over 4 is equal to 1, because they like the y squared term, they like the positive term first. And so that being said, remember, this here is my transverse axis, and it does connect my 2 vertices here and here. And the length of my transverse axis would be 6. Okay. So the last question is for hyperbola number 4 is find the equation of the hyperbola given the focal points, which are 8, 2. So 8, 2, up 2, there's 1 focal point. I like to put like an F or a V for vertice, or F for foci, and then 8, negative 8. So 8, here's 8, negative 8, which is down here. So this is another foci, which is at 8, comma, negative 8. Let me move this up. And this value is 8, comma, 2. All right, so what that tells me is 2 things. Number 1, it tells me that this is my part of my transverse axis. That's not the transverse axis, because the transverse axis connects your vertices. But what I can find is in between here. So I would say 5, 1, 2, 3, 4, 5. Halfway in between here, right? Halfway up, halfway down, which is 10. The difference is 10. So that would be 5 up, 5 down, is going to be my center. So that's telling me that my center, let's see, what is this going to be? This goes 8, comma, 1, 2, 3. So my center is at 8, comma, negative 3. So just starting off, equal 1. If I put x first, I know that this is x minus 8 quantity squared, and this is going to be y plus 3 quantity squared. Additionally, because my focus points are cut within my hyperbola, I do know my hyperbola is going to do this and this, right? Which means that it's on the y-axis, which means that my y-axis is the positive axis, and this is now negative, okay? We also know that the conjugate axis, now the conjugate axis is that axis that is not the transverse axis. It just connects the box together. That has a length of 4, which means over 2, right? So if